Right, so today, or for this lesson, we're starting to explore the topic of polynomial functions. And that's the unit that we're working on, okay? The last lesson, which is the first lesson of the course, talked about characteristics of functions, properties of functions. And we looked at all different kinds of functions, not just polynomial functions, because we were learning those new properties, intervals of increase, decrease, end behavior, and even or odd symmetry, right? So we learned some new properties on top of the old properties we had, things like intercepts, asymptotes, domain and range, and such. But now we're looking at polynomial functions, and that's what this unit is all about. So it's going to be all about these kinds of functions. But again, we're approaching this from the perspective of, so what are the properties of polynomial functions? And you could group polynomial functions into a couple of subcategories, and that will make more sense when we get there and actually talk about that, which we will by the end of this lesson. And when you do that, you can see that in those subcategories, they share certain properties, like always share those properties. So that's what we're looking for. We're looking to explore what a polynomial function is, what's it like, what's its graph like, that kind of thing, what's its equation like. We're going to look at that too. And we're going to do at least part of that in terms of its the properties of that function. Okay, so it really does have a lot to do with what we started exploring yesterday. So first, again, some definitions. A polynomial is an expression consisting of variables, and this is important, one variable for us, okay? So variables and coefficients, which involves only the operations of addition, subtraction, multiplication, and non-negative integer exponents. Now I'm going to come back to this idea of one variable for us. So if I write some kind of function, in this course it's all one variable for us, but let's say I write a function like this, y equals x squared minus 9. Well, you might say, but there's two variables in that. But I'm not talking about the output variable. I'm talking about input variables. We always only have one input variable. So if you had like y equals ab, that's called multivariable, and that's a whole different world that you wouldn't get to until you were in university. So we're only looking at single variable or one variable algebra, and even though this has two variables in it, it only has one input variable. So that's what we're talking about. So everything we do in this course has to do with that, okay? And again, look at this. We can do adding and subtracting. We can multiply. And division is similar to multiplying, right? Dividing by 2 is the same as multiplying by half, so they're related there. Same as addition and subtraction are related. And this is important, non-negative integer exponents. So keep that in mind. That's going to come into play in our first example. The degree of a polynomial in one variable is the greatest exponent on the variable of any of its terms. When you first started learning about degree, which I think was way back in grade 9, and I'm not really sure why, because you don't know, it doesn't make any sense and it's totally useless way back then. You do multivariable expressions. And if I have a multivariable expression, now be careful, you don't want to miss this up, but if I have a squared b cubed, that's just a monomial, okay, that's an expression. Its degree is 5 because I add the exponents, okay? But if I do a squared plus b cubed, this is multivariable again, but they're adding, not multiplying. So I do not add the exponents. The degree of this one would be 3, whereas the degree of this one is 5. So that's the difference. And in grade 9, you talk about that. I don't know why, because we don't do that. We're never going to look at that. That is totally uninteresting to us. Everything we do, we just look for the biggest exponent. And for us, since it's single variable, it's going to be something like this: x cubed plus x squared plus x to the 1 plus 1, let's say. The degree of this is 3. Okay, I do not add the exponents, never add the exponents. I'm worried even talking about it because I'm worried people are going to do it. Don't add the exponents. Just look at the biggest one. Okay, that's a first definition. You've seen that before. Leading coefficient, this is a new term, but it's pretty straightforward, is the coefficient of the term with the highest degree. I'll scribble in an example here as well. So let's say 4x squared minus 5x cubed plus 7x minus 1. What's the degree of this function? Be careful. Degree 3. Because that's the biggest. It doesn't matter where it is in the expression. This is kind of written out of order. It should be written first. but it's still degree 3. So the leading coefficient is the coefficient of that term, and we often call it A. So A is -5. Leading sounds like it's the first, so people would think it should be the 4, but this is written out of order. So leading coefficient is the coefficient of the term with the highest degree, okay? And that's the one that's dictating the degree of the entire function. And again, it's not clear why this is important, but it will be before the end of this lesson and before the end of the activity that we're going to do, or by the end of the activity that we're going to do, I should say. Okay? So those are two new definitions. Polynomial is one you know. Degree is one that you kind of know from before. But it's going to make a lot more sense throughout this unit why it's important. And then leading coefficient is kind of a new one, but it's fairly straightforward. It's just the number. It's just the coefficient, including the sign of the term with the highest degree. Generally speaking, a polynomial of degree n is written like this. So we write the coefficient of that term, x to the n, coefficient of the next term, n minus 1 just means the next term, and then x to the n minus 1 plus blah, 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 and then x squared, x to the 1, and this is x to the 0, right? So that's how we write them. You know that in descending order. So for example, I would write x to the 5 plus 2x to the 4 plus 7, x to the 3 minus x squared plus 2, right? So that's like 0x to the 1 plus 2. That's how we would write that. And that's a degree 5, leading coefficient is 1. That's how that works. And that's all this is saying. This is a way that you might, you know, if you're taking any math or engineering or even science in university, you're going to see these kinds of things where they just show it that way. It's the only reason why that's there. You don't need to really even understand that for now. It's fine. All it's saying is we write them in descending order as a general rule of thumb. That being said, sometimes they're not written in that order for whatever reason, so you do have to watch for that. Okay, hopefully there's no questions. Example 1, determine whether each of the following is a polynomial. If it is a polynomial, state its degree and leading coefficient, which is really what we're worried about, but we're going to notice a couple things that aren't polynomials, and that'll hopefully help us determine what is a polynomial. Hopefully we'll do this one quickly. First one, is it a polynomial? So in other words, does it fit this definition where the only operations involved are addition, subtraction, and multiplication, non-negative integer exponents? We have addition. We don't really have any multiplication. Is this a non-negative and integer exponent? Yes, it is. It's not negative. It's an integer. So yes. State its degree. So what is its degree? It's degree 2. What is its leading coefficient? Positive 1. Not very interesting, but there you have it. Okay. Now, that means a degree 2 polynomial is a quadratic. Like you were doing quadratics back in grade 10, but you probably didn't really worry about them as being called a degree 2 polynomial because you had nothing to compare them to. But we're going to look at degree 3, degree 4, degree 5, degree 6, all of these different ones in this course. And so that's the difference. Now, yes, we can think of it as a quadratic. Its graph is a parabola. We know a lot about that. But now we're also thinking of it as a degree 2 polynomial. So there you have it. What about this one? Is it a polynomial? Well, what if and some people might think it is and some people might think it's not. What if I did this? You remember that? You can take something that's in the denominator and rewrite it with a negative exponent. So that's what I did there. And we are not allowed to have negative exponents. So this is not polynomial. Now be aware, hold on, I'm gonna write something down that's not true, so don't write it down. Okay, this does not equal 3 to the x to the negative 1 minus 4 to the negative 1. You don't just expand exponents through a binomial or any polynomial like that. A negative exponent on an integer or on any number would be fine. On a constant, it's the negative exponent on a variable that we're not okay with. Okay, so this is not true, but this negative 1 is still on the x. In other words, the x is in the denominator, so that makes it not a polynomial. C, is it a polynomial? Yes, it is. This is your very straightforward, very clear great example of a polynomial. It's got multiplication. 2x means 2 times x. 5x to the fourth means 5 times x to the fourth. So it's got multiplication. It's got some addition, doesn't happen to have subtraction. And all the exponents are positive integers. Okay, so what's its degree? Its degree is 4, the highest. And even if this was written out of order, that would still be the degree. That's something that even though that sounds simple, that's something that people do have a hard time remembering. And the leading coefficient is the coefficient of that term. Okay, so A is 5. Next one. Some people might think yes, some people might think no. That usually is how this goes. It looks like it's got just adding and positive exponents, but the problem is this one is written in the wrong way. Okay, so it's not written as a proper expression. So how would I rewrite it as a proper expression? I would rewrite it like this, 25 minus x squared. And then what is that? That is y equals plus minus the square root of 25 minus x squared. And how do I rewrite root as an exponent? Y equals 25 plus minus 25 minus x squared to the 1/2. So that is not an integer exponent. It's a positive exponent, but it's not an integer exponent. So this one's a no. And again, this is not a question you're ever going to see on a test. Is this so-and-so a polynomial? So if you feel like this is kind of hard and you're like, well, how am I supposed to know that? Don't worry. This is not the kind of testing that we're doing. But it is giving us, hopefully easing us into this course and sort of seeing that, okay, we're talking about things that it's just the expression on the other side. Okay, we're not worried about the y part. As long as it's just y. If it's y squared, that's a problem. It's not written properly. If it's just y, we're good. And we're talking about what's on the right side of the equal sign. Okay, so maybe that's the lesson you learn from D. E. So it doesn't really have any operations, no adding, multiplying, that's fine. Does it have only non-negative integer exponents? No, its exponent is a variable, right? So this is definitely not a polynomial. It's exponential. This is a totally different one. Exponential functions are not polynomial functions. And what about this one? No. Sign, taking the sign of something is an operation. So that's another operation that's not allowed. This is a trigonometric function, not a polynomial function. These are both functions we will explore in other units of this course. Same with B. It's a rational function. We will explore that in another unit of this course, but those are not polynomials. So A and C are polynomials, and those are typical polynomials. That's the kind of thing we want to start getting used to. Okay, now we're going to do an investigation. So what you're going to do is you're going to pull out your device. Phone will be really tricky. I've seen kids try to do it. They don't work very well. So you want your Chromebook or a tablet or some other, obviously laptop would be fine, to do this with. And you're going to go to this link, okay? And I'm going to show you what that means in a minute. And here's what you're going to do. So you're going to use a graphing software to complete, the purpose of the... Okay, so here's what you need to do. In your notes, make a rough sketch of 3 different versions to compare. Rough sketch, okay? It doesn't have to look nice. You just want to be and even if you don't do the sketches, it's not a problem. If you can kind of get an idea just by looking at the software of what's going on, that's fine. But, once you get 3 different ones, maybe you sketch them and then you can remember, oh yeah, they can look like this or they can look like that. You're going to use the applet in the link to make them look as different as possible. And, that in some cases, that's not going to be very different. And you're going to think about these things. What can you change about the graphs as you play with the applet? What can you not change about the graphs as you play with the applet? And we're thinking about end behavior, and we're thinking about turning points. I haven't even talked about what that means. I'll talk about that in a minute. So the maximum number of turning points or the minimum number, the maximum number of X-intercepts, we do know what that means, the minimum number. And you're going to think of the leading coefficient, you're going to think of the end behavior, and you're going to think of X-intercepts and turning points and that kind of thing, okay? and what you can change, what you can't change. For degree 1 to 5, do as much as you can before we sort of stop this, or if you start to see the pattern and you don't need to do any more, that's fine. And you're going to do them with positive leading coefficient and negative leading coefficient, okay? And then, like I say, you can sketch them in your notes and think about these questions, and you can do this with somebody, but right now we're keeping our distance, so keep your distance. But you can be sort of chatting with somebody if you want to as you work through this. Okay, and I'm going to show you what this applet looks like when you bring it up. It won't look exactly like this because it'll be a web page, but now linear, you're not going to get that much different. So linear, I only have 2 sliders because I've only got 2 values, and I can, if I drag this one, notice that it just tips it back and forth, and when I do that, that's negative, so that's the other kind. So this is all leading coefficient. You can see the equation of the function there, okay, leading coefficient, and I can drag this one and it looks like it moves it up and down. But that doesn't change the leading coefficient. So here I'm changing the leading coefficient. Then I can drag it negative and it's just leaning the other way. You know, those straight lines are from grade 9, so hopefully we know a lot about that. Hit the reset button will take you back to proper values for all of these. When I go to quadratic, I get another slider because you've got 3 terms for that one, okay? And you can change some things. Watch what happens when I go to quintic. This is off the page. You might be able to fix that so you can see it. So I'm going to change a bit. Now, if I change a to negative, it's now a negative leading coefficient, so that's a different graph. So I'm going to leave a positive, and I'm going to start dragging these back and forth. And look at what I can do. Whoops. Look what I can do. Whoa. Okay, so I can make them look very different. Look at how the first one looked. Now, if I drag this up and this down, look at what's happening now. I've made it look very different. So I'm changing some things and I'm not changing other things. What do you think a turning point is? I think most of you are probably correct. That's this point where it's changing from increasing to decreasing. That's a turning point. And those are terms that we know, increasing and decreasing. So right there at the top of that curve, bottom of that curve, bottom, top. So how many turning points does this one have? 1, 2, 3, 4. Okay, what's the maximum? What's the minimum? That's what you're going to do. Okay, I'm going to let you work on that investigation. We'll work on that for a little bit. If you're doing this at home, I want you to pause the video and do the investigation. Try to get some idea. We're going to summarize it together. And you might have 20, 25 minutes, 30 minutes to do the investigation, to play around with it so you can watch the clock. And then we're going to do the summary. And you know, if you're struggling with it, that's okay. The summary is going to tie it together really nicely. Okay, so hopefully we finished that investigation, and we're going to try to summarize this. Now, what we're looking for is patterns in the different kinds of polynomials, and we're looking for things that are the same and things that are different, and any other similarities or differences throughout sort of all of the different ones that we looked at, okay? And some of this is already written out for us. These are basically the 2 different kinds of linear that you can have. So this is all positive leading coefficient, and this is negative. So the leading coefficient tells me that it's going straight up like this, and we called this a slope in grade 9. Negative leading coefficient, it slopes the other way, okay? Maximum number of x-intercepts is 1. What's the minimum number? Minimum is also actually 1, because if you had this is actually degree 0, so it wouldn't be the same, and it would have 0 x-intercepts, but technically a degree 1 will always have 1 x-intercept, okay? What are the maximum number of turning points? 0, minimum number 0, it doesn't turn, it's a straight line. It's odd, okay? I didn't mention that, but you during the investigation, maybe you noticed that it was even or odd. Or, sorry, it's an odd. This one's not, doesn't have odd symmetry. The degree is odd. And that turns out that that's important. Okay? Not super interesting. Let's get into some more. Quadratic. Okay? Is an even degree. It's degree 2, which is even. So we're going to summarize this because I talked about it, but we didn't get a chance to write it down. These are turning points. right? So the maximum number of turning points is 1. What's the minimum number of turning points? 1. It's going to have 1, right? It has to have 1. It's going to be a parabola. It's got to look like that. Maximum number of x-intercepts, 2. Okay, can it have more? No. Can it have fewer? I want you to think about that. This is something I'm not going to answer right now. Can it have fewer x-intercepts? What's the minimum number of x-intercepts? What are the possible number of x-intercepts? Can it have 0? Can it have 1? Can it have 2? Can it have 3? We already kind of said it can't have 3 because the max is 2. Okay, but that's the question that we're asking there. It's a parabola, obviously. What's its end behavior? What is the end behavior of this one? It's as x goes to negative infinity, and then as x goes to positive infinity, what does y do? Notice that they're both are pointing up or both are pointing down, and that's always going to happen, right? So for any quadratic, any degree 2, any parabola, your end behavior will either be both pointing up, so both going to infinity, or both pointing down. It has to work out that way. So this is one of those things where we've now noticed a property of quadratics, of degree 2 polynomials. We've noticed this property that both end behaviors will either both be up or both be down. Okay? Odd. So maximum number of x-intercepts is 3, maximum number of turning points is 2, but what are the possible numbers? How many x-intercepts could you have? Could you have 0? Could you have 1? I guess you could have 1 because there's 1 for that, right? That's not a turning point, by the way. We call that a twist. So this has 2 turning points. I did those in green before, so I'll do them 2 turning points, right? But you can change the number of turning points. You can change the number of x-intercepts. Can you have 0 x-intercepts? Let's hang on to that question. What is the end behavior of this one? It's as x goes to negative infinity and as x goes to positive infinity. What does y do? And same thing for this one. In this case, they don't both point the same direction. They point opposite directions. So if this one goes to negative infinity, this one goes to positive infinity. If this one goes to positive infinity, the other one has to go to the negative infinity. So that was something you hopefully noticed yourself during the investigation, that for this degree 3, which is odd degree polynomial function, they're always pointing opposite directions. One's pointing up and one's pointing down. Okay? And if one is pointing up and one is pointing down, can I have 0 x-intercepts? I hope you realize the answer is no, you cannot. So you're going to have at least 1 x-intercept. Was that same thing true for the even degree 2 polynomial? Okay, these are the questions that you need to figure out for yourself. I'm not just going to give you the answers because you're going to memorize them. I want you to visualize and think about it and get to a point where you get it and you're like, okay, now I'm getting this, right? Okay, degree 4, even. What do you notice? End behaviors are like the even polynomial degree 2, aren't they? By the way, degree 3 is called cubic, degree 4 is called quartic, degree 5 is called quintic, if you probably noticed that from the investigation, but they do have names, okay? We use cubic. After that, we usually just call them degree 4, degree 5, degree 6. So degree 4 is like degree 2. They're both up or they're both down. Degree 3 was like degree 1. They're both pointing different directions. What do you think degree 5 is? It's an odd degree function. Yes, they point different directions. Okay? What do you think a degree 6 would look like? We didn't see those. What would be your guess? It's an even degree, so they point the same direction, and that is true up to any number you want to pick. If it's an odd degree function, the end behaviors will be 1 up, 1 down. If it's an even degree function, the end behaviors will be both up or both down. Okay, so these are the properties that we need to know about. This is about polynomial functions. Other functions don't have degrees. This is about polynomial functions, and these are the things we need to know about polynomial functions. So now this one has 1, 2, 3 turning points. This one only has one. That's not a turning point. That's called a twist. So this one has one turning point. Right? The base function of a quartic, has one turning point. Can it have 0 turning points? Can it have 1? Yes. Can it have 2? Can it have 3? Okay, these are the questions that we need to try to figure out, because it helps us look for patterns and think about the nature of these functions. What can they look like? What do they have to look like? That sort of thing, okay? And it does take some time. One day is not even necessarily enough, but after a few days of thinking about this, you're really going to start to get there where you're getting where the patterns are and what's happening. Let's see, is there anything else that I didn't touch on? I think that's about it. Don't forget, we're also thinking about X-intercepts. That turns out to be really important because that has to do with solving these equations. So how many X-intercepts can it have? Some of them can have 0, some of them can't. What's the maximum number that they can have? How is that different from turning points? Okay, and we will take this up and we will talk about this. But I want you to think about not just the max and the min, but the possible numbers of these. How many could you have? Okay, that'll be important as well. I think that's it for now. So you've got some practice to do related to this. And like I say, we will take it up and talk more about it over the next few lessons.